Drake's equation. How much life is in the universe?
If you had the proper information, the variables needed to actually calculate that.
Yeah, but that's sample size, isn't it?
Well, true, but you need the information. I mean, when he came up with it back in the 60s, I believe, for all we knew, the only planets out there were around the sun. But you're the math guy. How about you start up with what the actual formula is?
Okay, the formula is... I'm going to give you each one of the things, and you're going to guess.
Okay, fair enough.
So then we get... It's a rough estimate, but it's not the scientific estimate. This is just our guess, using the Drake's equation. Okay, so the rate of the average star formation in our galaxy.
How do you mean like how many stars are born in each given time in our galaxy?
Yeah.
Well, let's see. We've got a galaxy with estimates between 200 billion and a trillion stars. So more stars were formed in the earlier days of our galaxy. It grows at a gradual rate at certain periods of time. But on average, that would end us up with several dozen stars per year. So let's make it even, say 25.
Okay, 25. And the fraction of those stars which have planets?
Upon the research we have, it's still difficult to say because we use what is probably going to be looked back at as a pretty rudimentary, primitive method of looking. I mean, we just look at the dimming of stars with things like the Kepler Space Telescope to find the dimming to figure out if there's planets around them, which means that the bigger planets which can't support life are the ones we're going to see first. But it seems that more stars have planets than stars don't. So let's say that's 50-50.
Okay, so 0.5.
Mm-hmm.
Okay. The average number of planets that could potentially support life per star.
Now that's a tricky one, because as far as I know, I had a note on this somewhere. Fuck, I really could use that note right now. Okay, I can't find it. We'll edit that in later. This is where it gets tricky, because as far as I know, we've discovered just a bit over 1,000 exoplanets, and by far the majority of them are gas giants, which can't support life in a way that we'd recognize it, at least to our knowledge. I believe there are some Earth-sized planets, but then if you don't get the right chemical components, you've got a problem. If you don't get the right atmospheric components, you've got a problem. So let's be modest about this and say that 1% of them can support life in a way we'd recognize it.
So 0.01. Okay, and the next one is the fraction of planets which go on then to support life.
10% of the planets we find have a potential for life, and 10% of those with potential actually develop it.
Okay, so 0.01 again. Yeah.
Exactly, fitting those two steps in one. Then you've got the next step is how many of the planets with life actually develop intelligence.
That is the correct definition.
Well, looking at our own planet, it's not a particularly large frame of reference. Basically, looking at the way we recognize life, anything we'd actually be able to detect and research, we haven't had multicellular life on our planet for 1 billion years or so, and life on our planet has been going for 3 to 4 billion years. It seems that the most complex forms of life arise the latest. So, providing that the planets don't enter some sort of sterilizing catastrophe, I'm going to be pessimistic about that one again and say before life has a chance to be wiped out, you're going to have probably 10%, which has an opportunity to develop intelligence before then.
0.1. And the not the last one. And the fraction of civilizations that develop technology to exist in space.
This kind of brings up an interesting point, because I may not have any evidence to support this, but it's nonetheless a pretty interesting thought experiment. How many, considering how long our species, in a way we'd recognize it, has been around, it took a very long time while we were around before we started to develop any sort of meaningful technology that enabled us to develop into a civilization. Only about 10,000 years out of the history of us that it's easily 1 million years old. So for only 1% of our existence have we had significant technology and civilization. So how many species have been out there, even just on planet Earth, which have been a formidable intelligence, but were wiped out before they had a chance to utilize the full potential of that intelligence?
The modern human is essentially only as long as our civilization has been around.
Yeah, but anything we'd recognize as a human, capable of speech, capable of relatively complex thought, a lot longer.
No. No, language developed roughly about 10,000 years ago. The way we would recognize it today.
That's highly subjective.
Yes, but I would think that would cover intelligence, otherwise you are literally just animals capable of using tools.
Well, we've got cave paintings that predate civilizations by tens of thousands of years, so that's a meaning of communication.
Yeah, I suppose. But still not long in the period of history of time.
Well, I'd say for the majority of our existence, in our current recognizable shape, we've not had technology and civilization. But that's a minority of our existence. So it is fair to reason that species which have the physiological potential of intelligence, of being able to develop that into something significant, there's a good chance they die out before they use that potential.
Yeah. Anyway, back to trying to do this. The fraction of civilizations that actually develop technology capable of existing in space.
Talking about actual civilizations, then I'd say that percentage is relatively high. I say again 50-50. Gradual exponential growth and development of your technologies and your potentials can go either one of two ways. Either you keep developing and improving, which eventually leads to leaving your home planet, or you wipe yourself out. And based on the variables I know of, I'd say that's 50-50.
And the final one is the length of time in which a civilization would exist.
Well, the longer you exist without wiping yourself out, the chances that you actually end up wiping yourself out gradually go down.
Which comes into the guess.
50,000?
50,000 years.
Oh, we've been around for 10. Do you consider our species to be spacefaring? We've sent robotic emissaries to another planet in our solar system, had a dozen people walking on the moon, and for the rest we've just been sending satellites to only slightly outside of our orbit.
Under the definition, I would say spacefaring. I'm capable of sending signals into space.
Okay. Well, then 10,000 years. I thought you were actually talking about colonizing planets beyond the home planet.
Yeah, that seems a rough estimate. I'm pretty sure humanity will still be able to send signals in another 8,000 years. But yeah, okay, all right, let me calculate this and see how many civilizations should be contacting us right now. Do you want to do it right? Drum roll, please. Right, the number of potential life forms which should be contacting us at the moment, according to our guesstimates, is 0.625.
That's reasonable.
Yeah, that's like we have slightly more than a 50% chance of being contacted by alien life. I think we've done this equation quite well.
So, basically, within our reach, likely to actually contact us, like within our galaxy, about a 62.5% chance that we're not the only ones.
Yeah.
Okay, but that's just counting on one other species, or what?
Yeah.
Okay.
Yeah, that's one other entity contacting us in our galaxy.
Because most of the versions of the Drake's equation I know, either those are wrong, or we've just done the maths wrong, counted on more than one civilization. Or is it not? Or is that not what you're gonna likely end up with?
No, I think it's because we've used more conservative estimates than the actual original Drake's equation.
Well, when it was first drafted in the 60s, it had obviously less research behind it and less reliable variables. So what we come up with right now is bound to be more accurate.
Yeah, that's probably true actually, because the main thing is that the original Drake's equation has less planets on it than our one, and has more 100% chance of life will develop on those planets where we have not gone into such things. But their strange estimate is that they have estimated that a civilization will last 100,000 years. No, sorry, 1,000,000 years. That was their average estimate before it would stop sending signals. Yeah.
Yeah.
Whereas we quite conservatively use 10,000 years, which is the fairest estimate of how long human civilization might last on this Earth.
Well, it's the only reference frame we have.
Yeah, so they've gone sort of a bit mad with that in the original equation, which brings their actual other ones are reasonably conservative, but so are ours. Actually, ours are more conservative, but yeah. Yeah, I think that is 0.65, 625. Yeah, I think that is a fair assessment of how many things there might be.
All right.
And I think that's a wrap. Yeah.